Welcome to Physics 30, Momentum and Impulse lesson. First question we should probably be having if we're talking about a new topic is on momentum and impulse is, well, first of all, what is momentum? Now, the definition of momentum is simply the product of mass and velocity. This is a technical definition, the correct definition, which means really if you were to take a look at that formula is just mass times velocity. Mass being in kilograms and velocity being in meters per second. So we've got a symbol for momentum, which is P. I honestly got no idea why it's P, but that is momentum, which means its units would be kilogram meters per second. But the definition is just the product of mass and velocity, multiplying the two together. Doesn't have a whole lot of real context, and as such, what we would probably like to do is actually just say, give it some sort of real life context. And in this case, I like the definition of quantifiable inertia. Oops. Little error there. Quantifiable inertia. And that kind of gives it a little bit of real life context. The tendency of an object in motion to stay in motion, or an object at rest to stay at rest. So the next thing we're going to take a look at is a definition of impulse. That definition of impulse is simply just the change in momentum. Change in momentum. And because it's just a change of something we already got, we don't have a separate unit for it. It's just simply the change in the mass and velocity product. The formula we've got for this is m delta v, which could be the change in the velocity multiplied by the mass. Can also be equal to the force times time. Both of these are equal to the change in momentum, although this is the only thing that's actually on your formula sheet. Please note that either side describes the magnitude of the impulse, not just one side, but both sides are doing that, which means that if we were to take a look at why would bungee jumpers use bungee cords rather than ropes? Well, really, this is to take the impulse over a greater time to reduce force. So, for example, if we've got a 100 kilogram person going down at 10 meters per second, but eventually wanting to come to an end at 0 meters per second. They're going down and slowing down and eventually reaching there. The change in momentum going 100 times 10 starts at 1,000, right? So this would be 1,000 kilograms meters per second going to 0 kilogram meters per second, right? We're seeing a change of 1,000 kilogram meters per second in terms of the momentum. If you take that over 1 second, you're going to see 1,000 newtons of force. If you take that over 10 seconds, you're only going to take 100 newtons of force, because the multiplication of force and time is also going to get you momentum. Notice that means that Newton seconds is also a viable unit for momentum as well as impulse. So our first example here, a 0.45 kilogram orange, so that's a mass of 0.45 kilograms, rolls down a hill. It accelerates from rest, so we've got an initial velocity of 0 meters per second squared at a rate of 2.5 meters per second squared down the hill. And it's doing this for a time of 5.4 seconds, and ultimately we're looking for the momentum. Now, momentum, being mass times velocity, means we need to figure out what the velocity is of this orange after 5.4 seconds. Well, we do know that the change in velocity is equal to the acceleration times time. So the change in velocity is going to be the 2.5 multiplied by the 5.4. Oh, there goes my pen again. And ultimately we're seeing a 13.5 meters per second change in velocity. Now, because VI is equal to 0, therefore we can assume that the final velocity is 13.5 meters per second down the hill. So we're really just going to take the 0.45 kilos and multiply that by the 13.5 meters per second in order to get a momentum of 6.1 kilogram meters per second. Okay. Example number 2. The orange in question 1, so this particular orange, right, is going to hit a wall at the bottom of the hill and come to rest in only 0.4 seconds. So we want to know the amount of force, right? Well, its change in momentum is negative 6.1 kilogram meters per second, because it's got this momentum of 6.1 kilogram meters per second and is coming to a complete rest. It's no longer is going to have a momentum of 0. So we can say that its change in momentum is equal to the force times time. Negative 6.1 kilogram meters per second is equal to force multiplied by the 0.4 seconds. So we're going to take that 6.1 and divide it by the 0.4, right? We're dividing both sides by 0.4. And that leaves us with a force of 15 newtons for the force. So a common concept is take the force over a greater time and distance in athletics, explain why this is mathematically, and really all this comes down to, again, is just that change in momentum is the product of force and time. You increase the time, means you see a decrease in force, because the change in momentum remains the same, regardless of whether you change that momentum over 0.4 seconds or 2 seconds or 5 seconds. And so this is why lots of things like foam mats underneath high jumpers and things like that, to reduce their momentum over a greater time and thus a greater distance, will actually reduce the force. Okay, I would like you to try this next question. Pause the video, give this a try, and then check here in a moment. Okay, so pause. Answer will come up in a couple of seconds. So the product again of force and time gets you the change in momentum or the impulse. You multiply both those numbers and you're going to get 0.3 Newton seconds or 0.3 kilogram meters per second. Either one is acceptable. You've got another question to try. If you've got any questions, please raise your hand, let the teacher know. Got another question to try, give this one a try, and we'll go from there. So in this case, we've got a 1.6 kilogram object, that's the mass. A 35 on at 1.3 seconds. That will give you the change in momentum. And so we're looking just for the change in velocity. We don't know what the final velocity is because we don't know what the initial velocity is, nor do we actually even know the direction. So really this would be a magnitude in the change in velocity or change in speed. But we put in our numbers, we're going to divide both sides by 1.6. And when you calculate that out, you should get 28.4 meters per second as being your change in velocity. So again, we've got a question here, old diploma question, which is the following units are correct for momentum. Momentum people usually initially go to, again, kilogram meters per second. However, as discussed earlier, newtons per second is just as good. This next question, again, diploma question. Really, we're just using one of these right now because the next following question beyond this on the diploma exam is something we'll be talking about later. But during archery competition, we've got an arrow with a mass of 35 grams or 0.035 kilograms. It's got a speed of 1.1 times 10 to the 2 meters per second, or 110 meters per second. And doesn't drop significantly during its flight, but it penetrates the depth of 5 centimeters, or 0.05 meters, before coming to complete stop. And what we were looking for is the amount of force. And so if you think about this, what we really need to know is the actual amount of time this arrow is slowing down in the board in order to find the force, because momentum, the change in momentum, mass times change in velocity, we know those two, but in order to find the force, we'll need the time, because again, m delta v is equal to force times time. Okay, because we're looking for the force, we need the time, mass and change in velocity. We can get those relatively easy. But the distance here is 0.05 meters. Its initial velocity being 110 meters per second, final velocity being 0 meters per second, means that we're looking for the time. Going back to the old kinematics formula, that's going to be d is equal to vf plus vi over 2 gets you time. That distance being 0.05. Final velocity plus initial velocity is 110 divided by 2 is 55t, or we get a time of 9.1 times 10 to the negative 4 seconds. So this is coming to a stop very, very quickly. But the mass of that arrow is not a lot. Its change in velocity, force, and 9.1 times 10 to the negative 4. Multiply these two, divide by time, you wind up with a force of 4,235 newtons, or to proper significant digits, 4.24 times 10 to the 3 newtons. At more questions about textbooks. What I would like you to do now is this video is over. You're going to complete these last couple of questions with your teacher, and then you can start working on the homework questions. Thank you very much, and see you soon.